Hello everyone. This video is on the Knewton Alta assignment for section 5.4 called Dividing Polynomials. So in this video I'm going to be doing a preview version of this particular assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same, so I'm hoping that watching me do a few of these here helps you out in some way when you work on the assignment on your own. Alright, so here's your assignment page. You should have your title, mastery bar. You should see the objectives. Looks like there are two objectives broken up into two different sections here. So it looks like we'll get 4 in a row from this and all the rest from this. Then beneath the current objective you have a question related to that objective. And then at the bottom of every question there should be a feedback button where you can send feedback to Knewton. You will not have this instructor cheat button. It's for instructors only. But you will have the more instruction button, where if you're struggling with a particular topic, click on this. It'll take you to a page with some reading or some videos or both, and then you'll be given questions related to that instruction, and you can get through the assignment that way if you wish. Alright, so the first objective is use lawn division to divide polynomials. So I'm hoping you recall how to do lawn division with numbers, with integers. Because if you remember how to do that, this should be no problem. There's just a lot more letters involved, a lot more terms. Alright, so I'm going to write this out, and I'll write through the steps that I'll be following to perform polynomial lawn division. So they're asking us in this first question to divide, and I'll actually write it out here, divide the polynomial negative 6x squared minus 3x plus 12 by the other polynomial 3x minus 3. Alright, so you could write the problem out like this. This is the same thing as the following, right? As taking negative 6x squared minus 3x plus 12 and say, take this polynomial and then divide it by, remember the division symbol, this obelisk symbol, 3x minus 3 after it. Means the same thing. Or this as well, you could write a division problem as a fraction, right? Negative 6x squared minus 3x plus 12 in the numerator, divided by, and then 3x minus 3 in the denominator. All right, and these all have special names, these polynomials, these parts of a division problem. So the first polynomial, right, which is the numerator, or the first polynomial in the division problem, this is called the dividend. The dividend, again, also the numerator, if you're writing it as a fraction. Alright, and then the polynomial you're dividing by, or this second polynomial in the division problem, or the denominator, this is called the divisor. And again, it's also the denominator in a if you were writing the division problem as a fraction. Okay, so lawn division is just another way of writing this problem. Right? You can write it out in words like this, or with this division symbol, or as a fraction. Or one more way, right? All these mean the same thing, But this is the one we're going to focus more on, is the long division. Right, and again, you hopefully are familiar with this symbol when you do long division of numbers. So it's like a little curl here, kind of like a parentheses within a big bar written above it, like that, connecting it. Underneath the symbol, underneath, to the right side of the parenthesis symbol there, you put the dividend in descending order. So negative 6x squared minus 3x and then plus 12, right? So here you put the dividend polynomial, the numerator polynomial, in descending order, right? Second power, first power, zero power. Then outside here, to the left of the parenthesis, right, to the left of the symbol, you put the divisor, also in descending order, highest power to lowest power, which is just 3x minus 3, right? Just 3x minus 3. You put the divisor out here. So dividend to the right of the symbol, inside the symbol, and the divisor to the left or outside the symbol. Right? Again, both in descending order. All right, so now the steps of long division. I'll start putting them over here. So the first step is a division step. Divide the lead terms, and the lead terms only. So when looking at these, right, the lead term of the dividend is negative 6x squared. The lead term of the divisor is 3x. So that's all I'm doing. Negative 6x squared divided by 3x, and if you were to simplify that fraction there, this would just be negative 2x, negative 2x, and that negative 2x gets written above the symbol, right here on the bar. And this is where what's called the quotient will be. I'll write that when we're done. Remember, the result of division is called the quotient, and then there will be some stuff left over called the remainder. So I divide the lead terms. That's step 1. Step 2. We then take this thing we just wrote, this term, negative 2x, multiply by the divisor. Right, so I'm going to take this negative 2x we just wrote and multiply it by the divisor, which is 3x minus 3. So I'm going to be distributing. It's going to be, negative 6x squared and then plus 6x. Right. So up here, though, I'm going to write it like this. We're going to take the term we just wrote, going to multiply by the divisor, and write the result underneath the dividend. Right. So again, that was negative 2x times 3x, negative 6x squared, and I'm going to write the results so that like terms are lined up. And you see x squared with x squared, and negative 2x times negative 3 is positive 6x. Right, and I'll line up x with x. All right, that's the multiplication step. Number 3. Subtract. Subtract the result from 2 from the dividend, right? Subtract the result from step 2 from the dividend, right, from the line above it. All right, so here's where things can be tricky. You're not just subtracting this first term, you're subtracting all of this from the line above it. So really you're distributing this negative to each of these terms here. So negative 6x squared, minus negative 6x squared, that's nothing. That'd be negative 6x squared plus 6x squared, that's 0. and then negative 3x minus positive 6x. Negative 3x minus 6x would be negative 9x. And then 12 minus nothing is still 12, so drop everything else, plus 12. Right? So now you can think of this negative 9x plus 12 as the new dividend, even though it's not the dividend. Right? Just think about it as the new dividend. And then the next, repeat steps 1 through 3 until the degree after subtraction is less than the degree of the divisor. See how this negative 9x plus 12, this is a degree 1 polynomial. The divisor is also a degree 1 polynomial, so this degree is not less than the degree of the divisor yet. So we keep going. So I'm going to say repeat 1 through 3 until the degree after subtraction is less than the degree of the divisor. All right, and that's a lot. I know, that's a lot. But divide, multiply, subtract. Divide, multiply, subtract. Those are the key words. And repeat, of course. You know. So, again, since this degree is not less than the degree of the divisor, I do it again. So we take the lead term of this, negative 9x, divide it by the lead term of the divisor. All right, negative 9x divided by 3x would be negative 3. All right, and then that negative 3 gets written in the quotient area. It's written up top. And then just negative 3 gets multiplied by the divisor. And then that result will be written underneath the negative 9x plus 12. So negative 3 times 3x would be negative 9x. Negative 3 times negative 3 would be positive 9. And now comes the subtraction step. I subtract, put a big minus sign here, and then all of this from the line above it. Don't forget big parentheses, right? You're subtracting each term. Well, negative 9x minus negative 9x would be 0. 12 minus 9 is 3. The degree of 3 is 0, right? The degree of a constant is 0. The degree of the divisor is 1. So the degree after subtraction is less than the degree of the divisor. I'm done. I'm finished. So now, what do we have? When you're done, everything I wrote, all the terms I wrote after those division steps above the symbol, that polynomial is called the quotient. And then what's left after the last subtraction, this number 3 here, this is called the remainder. All right, I guess you don't need the exclamation points. All right. So the quotient is negative 2x minus 3. The remainder is 3. Now, how do we express the result of a division problem? All right. So I'll come back to this. So you have dividend divided by divisor. All right, and how do we express the result? You're going to write this as quotient, whatever the quotient is, plus a remaining fraction, and that's the remainder . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . divided by the divisor. Okay, so this divisor stays the denominator of this little second term here. You have quotient plus remainder over divisor. Right? And this is how you express the result of a division problem. For example, right, if I took some numbers, say 11 divided by 3. 3 goes into 11 3 times, right? So the quotient's 3 plus, and then there'd be 2 left over, right? 3 times 3 is 9, plus 2 would be 11. So this is 3 2/3. Right? The quotient's 3, the remainder's 2. 3 2/3, 3 plus 2/3 is the same as 11/3. That's an example with numbers. Right, and we're doing the same thing here with our polynomial. So negative 6x squared minus 3x plus 12 divided by 3x minus 3 is the quotient, right? Negative 2x minus 3 plus the remainder over the divisor plus a fraction, right? And the remainder was positive 3 here, so plus 3 over 3x minus 3. And this is what we're asked to enter. Right? This is the result of that division. Quotient plus remainder over divisor. Quotient plus a fraction. Now, a way you can check. So I'm going to ask one more question. How do I check if I'm right before I start entering answers? So how to check your division? Well, remember how I said we can write the result here? Dividend divided by divisor equals quotient plus remainder over divisor. Pardon me. If I multiply both sides by the divisor, we get this. Is the dividend equal to the quotient multiplied by the divisor plus the remainder? I'm going to ask that question. If this is true, then this will be true as well. Because this statement I have here is exactly the same equation, but you just multiplied everything by the divisor. So let's see. The quotient was negative 2x minus 3. The divisor was 3x minus 3. And the remainder is 3, plus 3. So you multiply these two. I can do some foiling or whatever. Distribute every term from one to the other and combine like terms. That'd be negative 6x squared. And then we have plus 6x minus 9x. That'd be minus 3x. And then plus 9. Right, but then you got the plus 3 after, making that plus 12. Right, this is negative 6x squared minus 3x plus 12. And what, hey, isn't that the dividend? Negative 6x squared minus 3x plus 12? Yes, it is. So that means what I did was correct. I have the correct quotient. I have the correct remainder. All right, but again, this is how we're going to write the result, though. When you divide dividend by divisor, the result is quotient plus fraction, where that fraction is the remainder divided by divisor. All right, a lot of stuff, but I'll be doing 4 of these, I believe. All right, so should be seeing plenty of examples. So the result here, again, the quotient was negative 2x minus 3, plus, and then a fraction, remainder over divisor, 3 over 3x minus 3. Great. And after every answer submission, right, you should be told whether you're right or wrong, and given some sort of answer explanation. Please read through the answer explanations. Just make sure you see why things were right, why things were wrong, and hopefully you can learn from your mistakes for future questions. All right, so again, we're going to stick with this, long division. So I'm going to do this again. So here we have some degree 4 polynomial divided by a degree 1. And again, asked to write out the result of division, the quotient plus a fraction, the quotient plus remainder over divisor. All right, so I'll write this out. Now I'm not going to write it out in the 4 different ways that I did with the first problem. Just going to write out the long division. So here's the long division symbol. And inside goes the dividend, right, the numerator, in descending order. We have negative 45 x to the 4th plus 36 x cubed. Then there's a second power term, minus 15x squared. There's a first power term, right, minus 3x. And then the constant term is plus 16. All right, and then on the outside, or the left of the symbol, is the divisor, the denominator, in descending order, which is just 5x minus 4. All right, so once again, I'll go through the steps. I'll do it a little slowly again with this one. We're going to be repeating it a lot. So first step, divide the lead terms. So what's negative 45x to the 4th divided by 5x? That'd be negative 9x to the 3rd. Okay. Then we take whatever term we just wrote after the division step, you multiply it by the divisor, and then that result gets written underneath the line before in the dividend. So negative 9x cubed times 5x would be negative 45x to the 4th. Right, and it should be the same first term, right? You want those to go away when you subtract. And then negative 9x cubed times negative 4 would be positive 36x cubed. Right. So there's the multiplication step, and then the subtraction step. You big minus sign, put parentheses around this entire thing I just wrote, and we'll get a new polynomial. A new dividend, if you will, even though it's not the dividend. So subtract these, you got nothing. Same thing here, 36x cubed minus 36x cubed would be 0x cubed. So all I'm left with are these terms, just drop down. Negative 15x squared minus 3x plus 16. Right, because those are all being, subtracting 0. Okay. Now the degree of this polynomial is 2. The degree of the divisor is 1. So it's not less than yet. All right, so I have to start over. So now the division step. Divide the lead terms. The lead term of this polynomial is negative 15x squared. Divide by the lead term of the divisor is 5x. Negative 15x squared divided by 5x would be negative 3x, and I write that up here in the quotient. That's the next term I write, negative 3x. Then once again, this negative 3x, and only the negative 3x, is multiplied by the divisor, and the result is written underneath this line here. So negative 3x times 5x is, negative 15x squared. Negative 3x times negative 4 would be positive 12x, and I'll write that under the other x term. And I'm done with that multiplication step now. And now we subtract, right? So big minus and then parentheses, right? Make sure you're subtracting every term, right? Or distribute the negative if you want. First term should be gone, right? And then negative 3x minus 12x would be negative 15x. And then 16 minus nothing is 16. You drop the plus 16. Okay. So now, this polynomial here after subtraction has degree 1. the divisor has degree 1. So I'm not done yet. This degree after subtraction is not less than the degree of the divisor. So I have one. I see one more step of this, one more iteration of this. So let's do that again. Divide the lead terms. Negative 15x divided by 5x would be negative 3. So I write negative 3 in the quotient, and then multiply only negative 3. Only negative 3 gets multiplied by the divisor, and the result will be written under this negative 15x plus 16. Well, negative 3 times 5x is negative 15x. Again, the leads should be the same if you want them to go away when you subtract. And then negative 3 times negative 4 is positive 12. And then we subtract all that from the line above it, and we get the following. Right. First term's gone, and then 16 minus 12 is positive 4. And this has degree 0. The divisor has degree 1. We're done. Right, this has a smaller degree than the divisor. Alright, so once again we can point out the quotient and remainder. Right? The quotient is all these terms that were written above the symbol after the division steps. Right, there's the quotient. And the remainder is this thing here that's after the last subtraction step. Right, and then finally, how do we write the result of this division that they want? Right. So I'll cover this up real quick, and then we say that negative 45x to the 4th plus 36x cubed minus 15x squared minus 3x plus 16 divided by 5x minus 4 is equal to the following. There's the quotient, negative 9x cubed minus 3x minus 3 plus a fraction plus the remainder, which was just 4, over the divisor, which is 5x minus 4. Right? The remainder was 4. Right? And this is what they want. Right? The result of the division, the quotient plus some fraction plus remainder over divisor. All right, now I'll do the checking one more time here. Let's check by hand, see if we got this right. Is the dividend, write it out one more time, is the dividend equal to the quotient times the divisor plus the remainder? All right, so let's do quotient times divisor. So that's negative 9x cubed minus 3x minus 3 times the divisor times 5x minus 4, and then we're going to add the remainder to it, right, plus 4 afterwards. All right, now multiplying these two will require a lot of distributing. Right. So I'm going to distribute the terms of 5x minus 4 to the 9x to the one with 3 terms here. Right. So first I'll distribute the 5x to this negative 9x cubed minus 3x minus 3. That'd be a negative 45x cubed, then minus 15x squared, then minus 15x, and then distributing the negative 4, we get plus 36x cubed. Oh, sorry, this would be negative 45x to the 4th. Plus 36x cubed. That doesn't line up with anything else. Then plus 12x, so I'll go line up with the 15x, and then plus 12. But then don't forget we have plus 4 at the end, and putting all these together, combining like terms and putting them in descending order, we have negative 45x to the 4th plus 36x cubed minus 15x squared. Putting the x's together, we get minus 3x, and putting the constants together here, we get plus 16. And look, that is exactly the same as the dividend. Right? There was the dividend, that numerator polynomial. It's exactly the same yes, check. The dividend is the quotient times the divisor plus the remainder that I got. So my quotient and remainder are proper. And then the result of this division problem is, again, quotient plus fraction, quotient plus remainder over divisor, and that's what they want us to enter. So we have quotient, negative 9x cubed, minus 3x minus 3, and then plus some fraction plus remainder over divisor, 4 over 5x minus 4. And that should be good. I did do the checking. Great. All right. Next question is another one of these, another law and division. All right, so this time I'm not going to do the checking. I'm just going to perform the law and division. All right, so we're asked to divide. I'm going to make the law and division symbol. We have, the dividend is negative 42x squared minus 13x plus 1. And the divisor, we're dividing by 6x plus 1. Alright, so this time I'm not going to do all the writing. I'm just going to speak and write what my results are. So first I divide the lead terms. Negative 42x squared divided by 6x would be negative 7x. That goes in the quotient area. Then I multiply negative 7x by the divisor and write the result underneath the dividend here. That would be negative 42x squared and then minus 7x. And then I'm subtracting all of this. Right, subtracting each of these terms, which will make them both positive, really, because if you distribute the negative, the negative times negative will be positive. The 42x squareds are gone. Negative 13x minus negative 7x would be plus 7x. Negative 13x plus 7x would be negative 6x. And then you got the plus 1 still, right? That's 1 minus 0 is 1. Alright, then I start over because this is degree 1, that's degree 1. The degree after subtraction is not less than the degree of the divisor, so I keep going. Negative 6x divided by positive 6x would be negative 1. Then I multiply the negative 1 by the divisor. That gives me negative 6x minus 1. And then subtract all this. The negative 6x's would be gone. 1 minus negative 1 is 1 plus 1. That's 2. And then here's the quotient. I'll just put Q for quotient. Here's the remainder. I'll just put R for remainder. And so the result of division here would be negative 7x minus 1 plus 2 over 6x plus 1. Right, if I took the fraction negative 42x squared minus 13x plus 1 divided by 6x plus 1, this would be the resulting state expression. Quotient plus remainder over divisor. And you can check, is the quotient times the divisor plus the remainder equal to the dividend? You can do that check on your own, but I'm going to leave that to you this time. So quotient, negative 7x minus 1, plus the remainder over divisor, 2 over 6x plus 1. Great. All right, I should have one more of these. And once again, I'll just write it out. And I'm not going to do the checking afterwards. All right, I'll leave the checking to you. So law and division symbol. Inside goes the dividend, right, which in here is negative 24x to the 4th plus 39x cubed minus 18x squared plus 21x minus 18, right, in descending order like that. Divisor, what we're dividing by is 3x minus 3. Alright, so the first term, divide the lead terms, be negative 8x cubed. That goes in the quotient. And then you multiply by the divisor, that'd be negative 24x to the 4th and then plus 24x cubed. All right, then both these terms get subtracted from the line above it. The fourth power terms are gone, and 39x cubed minus 24x cubed would be 15x cubed. Then all the other terms just kind of drop down. And I start over. 15x cubed divided by 3x would be positive 5x squared. That's the next term I write in the quotient. Then 5x squared times the divisor would be 15x cubed, and then minus 15x squared. And then these terms I just wrote get subtracted from the line above it. The cube terms are gone. Then negative 18x squared minus negative 15x squared would be negative 18x squared plus 15x squared, giving me negative 3x squared. And then the rest of the terms just drop down. Plus 21x minus 18. Keep going. All right. Negative 3x squared divided by positive 3x would be negative x. Then you take negative x, multiply by the divisor. It's negative 3x squared. And then plus 3x. All these terms get subtracted from the line above it. The x squared terms are gone. 21x minus 3x is 18x. And then you got minus 18. And then 18x divided by 3x is positive 6. And then 6 times the divisor would be 18x minus 18. And oh, look at this. No remainder. The remainder is 0. And if the remainder is 0, that tells you something. All right. When the remainder is 0, and there's nothing left over, that means that the divisor is a factor of the dividend. In other words, the dividend is, quotient times divisor plus 0. Right. So basically, when the remainder is 0, we can factor the dividend. Right? These two are factors of the dividend. And again, you can check. Take the quotient times the divisor and see if you get the dividend back. Right? And then, because it's plus 0 afterwards. Right? But when we have a remainder of 0, that means we know how to factor the dividend. Right? That's key. All right, and if the remainder is 0, you just have to put the quotient when you're doing division, right? Because the remainder is nothing. That fraction, the remainder over divisor, that's nothing. That's 0 now. So the result of the division here is simply the quotient, negative 8x cubed plus 5x squared minus x plus 6. With no remainder, so no fraction being added onto this, right? Just the quotient is the final result. All right, so those were all examples of long division. And you can always take two polynomials and divide them with long division. Now, you may have noticed that every single one of the examples they gave us, we were dividing by a degree 1 polynomial. That doesn't have to be the case. We can divide by any polynomial with a degree less than the degree of the dividend, or less than or equal to the degree of the dividend. So if your dividend is degree 4, you can divide it by any polynomial that's degree 4 or less. It doesn't have to be a degree 1. Right? So please understand that all the steps I perform for long division here can be applied when the divisor has a degree higher than 1. Right? You can always do this long division. Okay. Now the other objective is on something called synthetic division. Now, synthetic division is very specific. You can only use it in certain in a certain scenario. Right. So I'll talk about synthetic division and when you can use it here. So synthetic division can only be performed when the divisor has the form x minus c, right, where c is some number. Or it doesn't have to be a real number, but I'll just say c is a real number because we're not going to really be dealing with imaginaries here. All right. So basically, when you're dividing, again, the divisor, when the divisor has degree 1 and lead coefficient of 1, so degree 1 and lead coefficient of 1. It's just 1x plus or minus some number. That's it. That is the only time you can apply synthetic division. Now you can always use long division. If you know how to do long division, you can do that every single time if you want. Synthetic division, though, is very much shorter. It's a shortcut for long division when you're dividing by a degree 1 polynomial with a lead coefficient of 1. So, look at their example here, right? Again, the question they're giving us is, take this degree 4 dividend and divide it by x minus 3. You see the divisor is a degree 1 with a lead coefficient of 1. So I can use this synthetic division. And see how they're asking us to write the result as quotient plus remainder over divisor, right, like I've been saying. All right, so what I'm going to do first is I'm going to show you, we'll do this with long division first. Okay, I'll do it with long division first, and then I'll show you how to perform synthetic division, when you divide by a degree 1 with a lead coefficient of 1, and you'll see that it's a lot less writing, a lot faster, and you get the same results. Right, you just have to know how to interpret the results, though. That's the hard part, I think. All right, so first, before we go back to synthetic division, we're doing 2x to the 4th minus 10x squared plus 16x plus 13, right? There's the dividend, dividing by then x minus 3. All right, so like I said, first I'll do long division. So here's just one more example of long division. So I write the long division symbol, right? Underneath it goes the dividend, the numerator, right? 2x to the 4th. Now notice there's no x cubed term. So here's something I like to do, and you don't have to do this, but just to make sure it's easier to line up like terms, I'm going to put plus 0 x cubed. All right, so just so I don't miss any powers going down. Again, you don't have to do this, but I prefer it. Right? And then the x squared term is minus 10x squared. All right, then the x to the first term is positive 16x, and then the constant term is positive 13. Right? And the divisor is x minus 3. All right, I'm going to perform all the steps I've been doing in the last 4 examples. Divide the lead terms, you get 2x cubed. Then multiply by the divisor, that'd be 2x to the 4th minus 6x cubed. And you see again why I wrote the 0x cubed, so it's easier to keep things lined up. Then we subtract all of this from the line above it. The x to the 4th terms are gone. Then no x cubed minus negative 6 would be plus 6x cubed, so that's positive 6x cubed. And then you got the rest of it dropping down, minus 10x squared plus 16x plus 13. And then we start over. 6x cubed divided by x would be positive 6x squared. And I multiply 6x squared by the divisor. That would be 6x cubed. And then minus 18x squared. Again, lining up like terms here. Then we subtract, right, all these terms from the line above it. The x cubed terms are gone. Then negative 10x squared minus negative 18 would be plus 18. Negative 10 plus 18 would be positive 8x squared. And then the rest of the terms would just drop down, plus 16x plus 13. Then I start over. 8x squared divided by x is positive 8x. And then, 8x times the divisor would be 8x squared. And then, minus 24x. And then all this gets subtracted from the line above it. The x squared terms are gone. Then 16 minus negative 24 would be plus 24. 16 plus 24 would be 40x. And then the plus 13 drops down. And then finally, 40x divided by x would be positive 40. Then I multiply the 40 by x minus 3. It would be 40x minus 120. Subtract all of that from the line above it. The x's are gone. 13 minus negative 120 would be plus 120. So it would be 13 plus 120, 133. All right, so there's your quotient. Put a Q next to it. Here's your remainder. So a quotient is 2x cubed plus 6x squared plus 8x plus 40. And the remainder is 133. So that was long division, right? And you've seen this several times now. And you can always do it, right? You can always set it up. I just showed you here, But since this divisor is of this form, it's a degree 1 with a lead coefficient of 1, x minus 3. X minus, the value of c is 3 here. But since the divisor is a degree 1 with a lead coefficient of 1, I can perform this thing called synthetic division. And here's how I was taught how to do synthetic division. And I'll be doing 4 examples of this. So hopefully if you don't catch it here, you can figure it out with the rest of them. So let's make a big cross, like a sideways long T here. And then, dividing by x minus c, right? X minus c is the divisor. I put in the lower left box here, I put c there. All right, so this is x minus 3. I'm going to put 3 down here. That means I'm dividing by x minus 3. All right, then in the upper right section of the box of this T shape, I put the coefficients of the quotient. All right, so up here, put the coefficients of the quotient, just the numbers, right? Just the coefficients, in descending order. All right, put the coefficients of the quotient in descending order, and don't skip any powers. Don't skip powers. So here's what I mean by that. The x to the 4th term is the highest power. That is a coefficient of 2, so I write 2. Now remember, there was no x cubed term. All right, there's x to the 4th coefficient. The x to the 3rd coefficient is 0, right? Kind of like back here when I wrote the 0x cubed. So that's what I mean by don't skip powers. 0x cubed. Then the x squared term has a coefficient of negative 10. The x to the 1st term has a coefficient of positive 16. And then the constant term is positive 13. Right? And then I put like a bar here, separating the constant term from the rest of them. What that bar is going to do, it's going to separate you'll see the coefficients of the quotient from the remainder. So what we're going to see in this lower right box here is the remainder when I'm all done. Right. And what we're going to see in this box here, in between the bars, these are going to be the coefficients of the quotient in descending order. Coefficients of the quotient in descending order. All right, so here are the steps. And I'll just draw little arrows and stuff. First step, the lead coefficient up here becomes the lead coefficient down here. You just drop the first one. So draw two. I'm writing the number 2 again. Then the rest of it is just a lot of multiplication and addition. You take 3 here, you take this value of c, you multiply by the number I just dropped down. That number gets written above the next column. So 3 times 2 is 6. I put 6 above the next column, above that 0. Then we add 6 plus 0 is 6, and that gives me the next coefficient in this quotient area. And then you just keep doing that. Multiply by the c, multiply by 3. 3 times 6 is 18. I write that above the next column. And then add 18 plus negative 10. That's 18 minus 10. That's 8. Multiply by 3, right above the next column. 3 times 8 is 24. Then add 24 plus 16 is 40. We got one more time here. Multiply by 3, right above the next column. 3 times 40 is 120. Then add 120 plus 13 is 133. And I'm done. You drop the first one down, multiply by c, and add. Multiply by c, add to the next column. Multiply by c, add to the next column. Multiply by c, add to the next column, all the way to the end. Now look at these numbers between the bars and in the lower right corner. These are the coefficients of the quotient in descending order. So the constant term is positive 40. Right, the last term should be the constant term. The x to the first term would be positive 8x. Then you have the x squared term would be 6x squared, positive. And then the highest power then would be x cubed for the quotient, 2x cubed. No need for a plus sign in front of that. So the quotient is 2x cubed plus 6x squared plus 8x plus 40, and then the remainder is 133. Now let's compare that to when I did long division. Quotient was 2x cubed plus 6x squared plus 8x plus 40. Hey, it's exactly what I got doing long division. The remainder, 133. Exactly what I got doing long division. And a lot less writing. Takes up a lot less space. But once again, this can only be done when the divisor is a degree 1 polynomial with a lead coefficient of 1. It looks like this, has the form x minus c. And if it's x plus a number, you can always write that as x minus a negative number, right? But the very, very specific scenario, though, you have to have a divisor that's degree 1 with a lead coefficient of 1. It's gotta be that way. All right, so now that I have the quotient and the remainder, I can write the result of this division. Right? And they're even telling me how to, right? Now, I said this in previous problems, right? The result of division is the quotient, right? 2x cubed plus 6x squared plus 8x plus 40, and then, the quotient plus a fraction, right? Plus the remainder, 133, divided by the divisor, x minus 3. There's the result of dividing these two polynomials. And again, if you want to check, I know it's right, it says I'm right, but if you want to check, take the quotient, multiply by the divisor, and then add the remainder, and you should get the dividend back. All right, let's do that again. Now this time I'm not going to do long division. All right, this time I'm not going to do long division because they're telling me to use synthetic division, and long division and synthetic division will give you the same result, so no need to do it twice. All right. Okay, so they're asking me to divide this degree 4 polynomial, this dividend, by the divisor of x plus 4. So you see that's a degree 1 with a lead coefficient of 1. So I can divide using synthetic division. Now x plus 4, all right, the divisor is x plus 4, which is the same thing as x minus negative 4. So this negative 4 is the value of c, when I talked about dividing by x minus c. So when I set up the synthetic division symbol here, that's what I'm putting down here in the lower left corner is negative 4, not positive 4. Basically, the value of x that makes this 0, right? If x were negative 4, it would be 0. Okay, then up top, the coefficients of the dividend in descending order without skipping any powers. Now there was 3x to the 4th, that was the highest one. There was negative 3x cubed. There was 16x squared. Negative 11x to the 1st. And then negative 31 was the constant term. And then again, I like to throw a bar here before the constant term, and that bar will separate the coefficients of the quotient from the remainder. All right, now the first coefficient just drops down. Then we multiply, add, multiply, add, multiply, add, all the way till you're done. So negative 4 times 3 is negative 12. Negative 12 plus negative 3 is negative 15. Then I do it again. Multiply by c, add to the next column. Negative 4 times negative 15 is positive 60. 60 plus 16 is 76. Let's do it again. Negative 4 times 76, well, it's 4 times 70 is 280. 4 times 6 is 24. So it'll be 304. Negative 304. And then add, well, this becomes more negative, negative 315. And then negative 4 times negative 315 would be positive 1260, 1260. And then add, basically to subtract 31 from that, that'd be 1229. And there you go. So the quotient would be, remember, this would be the constant term, negative 315. Then first power, second power, third power. This would be a third power, third degree polynomial. 3x cubed minus 15x squared plus 76x, and then minus 315. And then here's the remainder of 1229. And again, they wish for us to put the result of the division in the way that you normally do, that quotient plus remainder over divisor. All right, you can check it if you wish again. Take the quotient, multiply by the divisor, add the remainder, and see if you get the dividend back, but I'm not going to do that. So the quotient, 3x cubed minus 15x squared plus 76x minus 315 plus some fraction with the remainder 1,229 over the divisor was x plus 4. And submit. That should be good. Excellent. All right. Great. Now they're doing synthetic division underneath. I was taught that above way with the cross and everything, the little sideways t. They give you the same stuff, right? It's really the same stuff. I don't know. I just do it the way I prefer it. That's all. All right. So looks like we're gonna do 2 more of these. So again, here, the dividend. Now notice there's no third power. So, I'm going to put a 0 for that. And then dividing by a degree 1 with a lead coefficient of 1. So I can use synthetic division. So let's do it on the same page. There's plenty of space. So this time, the divisor is x minus 3, right? So the value of c is 3. Right. Draw my synthetic division cross thing. Putting c here, 3, right? Up top right, the coefficients of the dividend, 1x to the 4th, 0x cubed, negative 2x squared, negative 4x, and negative 48 is the constant term. So I'll put a bar before that. Separate the remainder and quotient. Again, don't forget the zeros. That is the biggest mistake I see people make with this, is they forget they miss powers. Right. All right, then the first one just drops down. Right. And then we multiply by c, add to the next column, and just keep repeating that until you're done. 3 times 1 is 3, plus 0 is 3. 3 times 3 is 9, plus negative 2 is 7. 3 times 7 is 21, plus negative 4, or just minus 4, will be 17. And then 3 times 17 is 51. And plus negative 48 or minus 48 is 3. All right, so the quotient, let's put q this time, is, again, this is the constant term, 17 for the quotient. So then first power, second power, third power, this is another degree 3, 1x cubed plus 3x squared plus 7x plus 17. And here's, the remainder. I'll just put r for remainder, the remainder of 3. Now we're asked to write the result of division like normal, right, with the quotient plus remainder over divisor. So again, the quotient is x cubed plus 3x squared plus 7x plus 17, and then plus a fraction, right, plus the remainder over the divisor, 3 over x minus 3. Okay. I should have just 1 more of these. So notice again, once again, the dividend is missing a third power, so I'm going to have a 0 there, where there would be the coefficient of x to the third. And we're dividing, once again, by a degree 1 polynomial with a lead coefficient of 1. If that is the case, we can use synthetic division. All right, so this time the divisor is again a degree 1 with a lead coefficient of 1. It's x plus 5, which is the same thing as x minus negative 5, right? So this is the value of c, the negative 5. So that's what I'm going to put here in the lower left corner of my t, my cross. And in the upper right area, right, the coefficients of the dividend in descending order, 1x to the 4th, 0x cubed. Don't forget the missing powers, right? Negative 10 x squared, negative 13 x to the 1st, and then the constant term is negative 50. And then again, I like having a bar here to separate the quotient from remainder at the bottom. All right, first one drops down, then we multiply by c, add to the next column, and you just keep repeating that. So negative 5 times 1 is negative 5, plus 0 is negative 5. Negative 5 times negative 5 is positive 25, plus negative 10 or minus 10 would be 15. Negative 5 times positive 15 would be negative 75, plus negative 13 would be negative 88. Then negative 5 times negative 88 would be positive 440, plus negative 50 would be positive 390. Okay. And so the quotient, right, looking at these coefficients here, it's another degree 3 again, right? So it'd be x cubed minus 5x squared plus 15x minus 88, and the remainder is 390. And that should be enough. Right, I'll type this in. The quotient plus remainder over divisor, quotient plus fraction. The result of division, x cubed minus 5x squared plus 15x minus 88. And then plus the remainder over divisor, plus 390 divided by x plus 5. All right, and that should be good, and that should be the last problem in this preview version of this assignment. As I said at the top of the video, please understand that the questions I saw here may not be the same questions that you see when you work on the assignment on your own. But the objectives are the same, so I'm hoping that watching me do a few of these here helps you out in some way when you're working on the assignment on your own. And thank you very much for watching.